In the meantime, basically, the antiderivative of a function is the thing that if you differentiate gives you the function that you're antidifferentiating. That seems as though it's almost gibberish until you really think about it. For example, if I said to you in A, what is the antiderivative of the function, and we use capital F of x here, although even today we'll see that notation is kind of loose and fluid. You could very easily say that x squared plus x is an antiderivative of f of x in part A, because the derivative of x squared plus x, because the derivative of x squared plus x will give you 2x plus 1. Am I right? Okay. The only issue is x squared plus 1 plus pi will also give you a correct antiderivative, because if you differentiate that, you still get 2x plus 1. So this is where that concept of writing plus c comes in, where c is, it's sometimes called an arbitrary constant. I don't know why the word arbitrary is used. It's a constant. It can be any number you want. I guess because arbitrary means you don't know what it is necessarily. That's going to change a little bit today. So in all of these questions, and I did neglect or forget to mention yesterday that don't get tied down or mixed up with what that means. It just is basically saying the function is defined everywhere, so the antiderivative that you find is defined everywhere. And in some of these questions, I think they say, what is the antiderivative on 0 to infinity? And I guess the reason they're saying that is at least one of these functions is only defined from 0 to infinity, b. Does anybody have any questions you would like me to go over? Of course, so there aren't any questions, but I do want to just, talk about, I think it's number 6. Well, we'll do 7 first. I think 7 is easier to understand. You have to kind of reverse engineer your answer to make it work. So for example, in A, we would start by saying, well, capital F of x is e to the x squared, because I know that when I differentiate e to the x squared, I get e to the x squared, plus I get 2x, not plus. As well, I get 2x multiplied by. So if I differentiate this, if I take the derivative of what I believe the antiderivative to be, I'll get e to the x squared times the derivative of x squared, which is 2x. And this is where what I call the reverse engineering comes into play. I don't want a 2 in front of the x. When you take a look at what I'm supposed to get in A, for the derivative of the antiderivative, I'm supposed to get just x e to the x squared. And in order to prevent that 2 from being there, I can put a coefficient of 1/2 in front. So between 7, you have to play around with that a bit. And 6 is kind of the same thing, but I think you're playing around with negatives in some cases. That, for example, if I take a look at B, the antiderivative of 1 over x is the natural logarithm of x, minus the antiderivative of 1 over 1 minus x, we suspect is the natural logarithm of 1 minus x, except that if you, and I better be careful here, just give me a second. No, I put plus c, I just wanted to make sure. What about 7? Did I put plus c? Plus c. We'll put plus c in the end here. But if you believe that's the antiderivative, then you have to differentiate this. And when I differentiate this, what I get is 1 over x, which is just fine. That's what we want. We want a 1 over x. And then I get minus 1 over 1 minus x times the derivative of 1 minus x, which is negative 1. Uh-oh. That's going to change it to a positive, and I don't want it to be a positive. I want it to be a negative. Well, that's okay if I do this. That reverse engineering is taking its role here. If I put a plus there, then everything does work out and I will get the negative, which is what I wanted. So you want to be careful, at least with this beginning part to the unit where we're just kind of using trial and error, almost a guess and check. It's an intelligent guess and check. You're not throwing darts at a board with your eyes closed. You know, you're using common sense, but you want to check things. So then our final answer would be plus C. And if I forget C every now and then, that's okay. I sleep well at night. You can't forget C on the exam, right? Or an assignment. I mean, I said yesterday I'll take off like half a mark every time it happens. I may not do that, but you'll probably lose some marks somewhere.